In this little video, I just want to talk to you about writing a conclusion or results. Should take you about a page, page and a half to do. First of all, I want you to recall what the experimental statement or goal was. It said that pressure increases with increasing depth according to the formula P equals P naught plus rho GD, where P naught is the pressure at the surface, rho is the density of the fluid, G is gravity in units of 32.2 feet per second squared, and D is the depth in feet. Measure the pressure at various depths of seawater to determine the surface pressure P naught and the density of seawater. Note that the accepted surface pressure at sea level is 14.7 psi, or 101 kilopascals, and the density of seawater is 1029 kilograms per cubic meter. So that's what they wanted us to do. And we graphed our data, right? We found our data, we graphed our data, we found the best fit, and we wrote down the equation of the best fit line. Right? Pressure versus depth. Okay, so what do we do if we write a conclusion? Well, we want to discuss all our results. So there's a bunch of questions for you to answer in your discussion, conclusion, results. What did you do? Just a brief couple of lines to recap essentially the goal. What did you find? Well, what's your results? Then you want to do some more analysis, and this is the stuff that's a little more higher level than the things you've been doing. It's asking for some judgment. How well did you do? And again, how could you do a better job the next time? So let's move down a page. What did you do? Well, this part is just a restatement of your goal. I measured the pressure at various depths of seawater. I then plotted pressure P versus depth D to determine the surface pressure P naught and the density rho of the seawater from the equation P equals P naught plus rho GD. I fit a straight line to the experimental data. That's what you did. So now you get to discuss your results. My data and estimates of experimental uncertainty are given in Table 1. My graph is plotted in Graph 1. The equation of the best fit line is this. Notice I'm using correct sig figs. I'm using the symbols from my graph. So the things that I get from the graph, the slope and the intercept, are clearly spelled out. Then you discuss both your intercept and your slope. The accepted value of the surface pressure is 14.7 psi. Well, that's well within 12.8 plus or minus 2.8. This goes from 10 to 15.6. So we're within experimental uncertainty. The slope is rho g, but the units are funny. It's psi per foot, and so psi is pounds per foot, pounds per inches squared, and so there's 12 inches to a foot, so psi per foot is 144 pounds per foot, so you'd have to multiply this by 144. If you divide by g in feet per second squared, you get slugs per foot cubed. And in common units, that's mass per volume. And you can find the conversion for that, and it works out to 1065 plus or minus 70 kilograms per cubic meter. And again, the accepted value for the density of seawater is in that range. So perfect. We've actually got the numbers and we're agreeing with what we expected. Just a couple of notes here. Always make sure the equation stands out. You put it on a separate line so it stands out nicely. You should always discuss the slope and the intercept. Often the intercept is 0. You say, if you expect it to be 0, is it 0 within experimental uncertainty? You must do that. Okay, so what we do next is we discuss how good a job we did. Well, if you look back at the graph, we go back up here and we look at this graph. you see that the best fit line does not pass through all the data points within uncertainty. I flashed it too quickly for you really to see that, but in the lab, it's your lab, you've already seen that. Okay, so that doesn't matter. It's okay if they don't agree with an uncertainty. Nothing says it has to. The uncertainty and the pressure needs to increase by a factor of 3 to get agreement. Right? So if you're not agreeing, how much are you off? Now, it could be that you have bigger uncertainty in the depth. That would be your horizontal error bars are much bigger. But, you think about how you did it, and the depth measurements are easier to make than using this instrument to measure pressure. And what you think then is that the uncertainty the manufacturer gave was 1%, but you're off by about 3%. So maybe that's telling you something about the sensor. Perhaps the sensor is old and beat up a bit, and maybe it needs to be recalibrated. Because you're so far off, you don't need to discuss what was the largest source of uncertainty and how to increase precision. They're not relative here because your error bars are way too small. There's other concerns. So finally, what would you do next? The results agree with the expected values within the uncertainty of the data. So that makes it seem like the equation is working well. However, the spread of the data about the best fit line is much worse than expected. If the thing I would do next is I check the calibration of the pressure sensors before making more measurements. That's the sort of thing we're looking for. Now, on the other hand, if the data were in agreement, you would look for the largest source of uncertainty and talk about how you would improve the precision of your measurements. But it doesn't always work out like that. Okay, thank you. Good luck rating your conclusions.